We're going to be looking at the calculations involved with electrolysis now to see when we do electrolysis, how much of our product we are able to form. All right. So our topic would be calculations of electrolysis. So calculations involving electrolysis. That's our topic. So first thing I want to say to you is that the amount or mass of products formed at the cathode or the anode depends on the number of moles of electrons that were discharged. So the amount or the mass of our products formed at our electrodes depend on the number of moles of electrons that we had discharged. So electrons are very critical for this process here. Now it takes 96,500 coulombs. So the C represents coulombs. C represents coulombs. Let me just put it in brackets. Of charge to discharge 1 mole of electrons So if you want to move 1 mole of electrons during electrolysis, you need to get 96,500 coulombs in order to get 1 electrons to move. Now, I want to show you how we're going to get to the coulombs now. How do we know what is a coulomb? All right. Now, 1 coulomb is a unit or is the unit of charge. So coulombs is the unit of charge. It is found by multiplying so the current is found by multiplying the current supplied by the time in seconds. So to find out how much charge you were given or supplied within your cell, you must know what was the current that you were given for the amount of time that you were supplied for with that current, and that will allow you to get the coulombs. All right. Now let us look at it. Q is equal to IT. So I want you to know this equation. Q, which represents our charge. So Q represents our charge, is equal to I, which represents our current, multiplied by our time. And the critical thing for this is that you must always convert your time into seconds. So now, let me show you the link. So when we after we calculate, let me just give you some steps. So after we calculate the total charge supplied to the cell, then we determine, so after we calculate the total charge supplied to the cell, then we determine the number of moles of electrons that can be discharged by that. By the charge calculated. We're going to pause right at about this point and let us see if we can apply that knowledge to something. All right, let me see. Let us look at an example. For example, a cell was supplied with 2 amperes of electricity. So 2 amps represents our current for 1 hour. What is the charge? That's our first question. So if I gave you a current of 2 amps that flowed for 1 hour, how much charge would that be equal to? So what is the equation that we should use to find our charge? Q is equal to I times T, okay? But the only thing though is that our time should be in seconds, but they gave us the time in an hour. They gave us 1 hour. So let us see if we can work that out to the side. What would be our time in seconds? So because we can't put the 1 hour in the equation, right? So how many minutes are in an hour? 60 minutes. And how many seconds are in a minute? 60. So we will multiply our 60 minutes times our 60, and then we'll see the total number of seconds we have. And that would be how much? 3,600, right? So now that we have done that calculation to the side, let us go and work out the charge. Because they told us our current was 2 amperes, and now we know our time was 3,600 seconds. So let us see our charge now that we can get from that. Anybody at home? What would this work out to give us? Anybody? 42,000 you got?
It's 7,200.
7,200, and our units should be C, which represents coulombs, right? So everybody should be able to work out the charge. time multiplied by current. The only challenge sometimes is that they don't give you the time in seconds and you have to convert it into seconds. Okay. Now, once you have the charge, your job is to see how many electrons you can move with that charge. All right, so let us now look at that part now. So calculate the number of moles of electrons that can be discharged. With the calculated, or with the 7,200 coulombs. So now we have to see, what can we do with our 7,000 coulombs? We already know that if you want to move 1 mole of electrons, you need 96,500 coulombs. And I'm going to introduce you to something that is easy for you to write. Instead of writing out the 96,500 all the time, you can call it 1 farad. So 1 farad refers to 96,500. Now, if you only have 7,200 coulombs, let us see X. That is X. We don't know how many electrons we can get, so let us see how many electrons we can get from that 7,200 coulombs that we have. So whenever you get to a situation like this, where you make one statement at the top, and you make another statement down the bottom. So 96,500 gives me 1 mole of electrons, but I only have 7,200, so I will get X mole, and we don't know what X is yet. So how you're gonna solve this question is that you're gonna cross multiply. So you make 2 statements like this, you cross multiply. So you're gonna go like this. And I'm gonna show you step by step because I don't want you to miss any of the steps. So let us see. The X from down here is going to multiply this one from the top. So we're going across, right? So 96,500 coulombs times X would be equal to this times that, which is the 7,200 times 1, right? So that's how we cross multiply. So anything that's down here multiplies what's up here. Anything that's up here multiplies by what's down here. So now we have to solve for X. So X is now going to be equal to 7,200 divided by 96,500 coulombs. And let us see now what mole that would give us, that would turn out to be. What did you get? 0.075 moles. So with just this the 7,200 coulombs we have, we could only push the 0.075 moles of electrons. Persons understanding at home so far?
Yes, miss.
Okay, and you're understanding here. So basically what I want you to know at this point is that if I give you the current and I give you the time, you should be able to work out the charge. And you can also use that charge to see how many electrons you can get. Now the next part of the puzzle is that you write the half equation. Write the half equation of the reaction at either the anode or the cathode. So sometimes you're going to be interested in the anode, sometimes you're going to be interested in the cathode. And the reason why you need to do this part is that you need to know how much of your substance you can get based on the electrons that you have discharged. So from the equation, determine the ratio between the electrons and your product. And I must tell you that there are going to be several ways that you're going to see this being done at school. I don't have any problem with you doing it the way you learned it at school. The important thing is that once you're using the right principles, I'm fine. And I am doing it the very long way now because I want you to see exactly what are the principles. But when I'm finished with that, I can show you a shorter way you could do it. But you first must understand the principle before you start doing shortcuts. Because if I just show you the shortcut, what you're going to do is that you're going to just start copying what I did without understanding the principles, and I don't like that. So this is why I'm showing you the long way. So for example, say for example, we were looking at a reaction at the cathode and we were forming copper ions. So just say for example, we did electrolysis and at the cathode, copper ions were gaining 2 electrons to form copper solid. What I can see from this reaction is that it takes me 2 electrons to form 1 copper atom. So this means that the ratio between my electrons and copper is a 2 to 1. Okay? So now, okay. So this, what I have done here, I have seen what is the ratio between my electrons and my product that I'm interested in. 2 to 1. So for every 1 copper I need 2 moles of electrons if I wanted to form 1 mole of copper, right? Now, let's just look at how we can tie this all together. Therefore, it takes us 2 moles of electrons, So 2 moles of electrons, according to this equation here, would be able to form us 1 mole of our copper. However, we only were able to discharge 0.75 moles of electrons. So we can work out how much copper we expect to get from that. All right, I'm going to do it like this and then I'm going to show you a shorter version after I'm finished. So we are going to say how much copper would we get if we need 2 moles of electrons to get 1 mole of copper and we only had 0.075 moles of electrons. How much copper can we get? So this is a time now when we are going to do a cross multiplication again. So we're going to cross multiply. Whenever you make 2 statements like this, your job is to cross multiply. So it's going to be 2 times the x is equal to 1 times the 0.075. So that means that 2x is equal to 0.075. And then x would be equal to 0.075 divided by the 2. So what would be the answer here? Okay. So it means that based on the amount of electrons I could discharge, I could only form 0.0375 moles of copper. Now, a lot of times though, they might want to give you, they might be asking you for the mass of copper, right? So you should be able to convert, although I haven't done the mole concept yet, so I know you might not fully understand it, but I just want you to know enough to be able to calculate this. So how to convert our moles that we just got here to mass. Now in this case, what we'll do, mass would be equal to the moles times the RMM. And you might be asking yourself, what is the RMM? You have to look on the periodic table to find out what is the RMM of our copper. And I'm going to show you how to find that on the periodic table. So I want you to find, look in your past paper, your paper 2 past paper books. Let me just show you how to find that. So the paper 2 book, so let me show you how you're going to find the RMM of any substance that you need to find. So it's a paper 2 book, yes. Look at the very front of it. You will see a periodic table. So let me just show you at home. If you look in your paper 2 books, you will see a periodic table. It's right at the second page here. All right. So for each substance that's there, there's a number beneath it. That is the RMM of the substance. All right. So let us find our copper on this periodic table and see what is its RMM. So here is our copper right here. So the bottom number down here, this is the number that we need from the periodic table for the copper for our RMM. And it is 63.55. So if you found it, so make sure you can find it for yourselves, because when you get other questions, you're going to have to find other atoms, right? So copper's RMM, according to the periodic table, would be 63.55. So I'm going to use this information now. Persons at home, were you able to see it?
Yes,
Yes, miss.
But for any substance I ask you, so if I was asking you, for example, about iron, you would have found iron and you'd look at this bottom number down here, you know that is your RMM. All right. So let us go back to the question. Now that we have that information about our copper, that it is 63.55 for the RMM, let's go back and put that information in. So from the periodic table, the RMM is 63.55. And we normally add grams to it. Well, let me put, I normally add grams per mole. So let me just write that properly. So the number that you got on the periodic table, you can add grams per mole beside it. And that tells you the RMM of a substance. Yes. You can, but don't try not to round it off. So if the CSEC questions give it to you as 64, then work with what they give you in the question. But don't be too quick to round them off, right? So what this number tells you, let me tell you what is the importance of knowing the RMM. It tells you how much 1 mole of a substance weighs, right? It tells you how much 1 mole weighs. So if I wanted to know how much 1 mole of copper weighs, I could look at the periodic table and I can say 1 mole of copper weighs 63.55 grams. That is that's the significance of getting that number from the periodic table. So 1 mole of copper weighs 63.55 grams. That's the importance. So now, how do we find the mass? We knew from up here that we had been forming 0.0375 moles of copper. So I'll put that in right here. And we looked at the periodic table to find the RMM of copper, which was 63.55. So when we work it out, we can now see what mass of copper we would have produced. Work that out for me and tell me what mass it is you get.
Miss, I got 2.38.
2.8 grams. Okay, good. That's what.
2.38 grams.
Okay, thank you. Thank you. 2.38. Now, let us see how this all ties together now that we have. It's really been a long route I've been carrying you through, but I'm going to show you how it really ties together. So we are saying from, remember, let us go back to the original question, let's go back from up here. The original thing is that we supplied a cell with 2 amps of current for 1 hour. And we wanted to see how much copper we could produce from that 2 amps for 1 hour. So after all of that calculation, we realized that we could have produced 2.38 grams of copper. That's the essence of what we were trying to do. All right. Now, if you understand that concept, I'm going to show you how you could have done another question using the same principles, but now we're going to make it shorter. Yes. Yes, RAM or RMM, yes, it's the same thing. Most times we call it RMM when it's a compound, and when it's just one atom by itself, we call it RAM. But just not to confuse you, I just call it RMM all the time. All right, let us see now if we could have done this, a similar question in a shorter way, but now we understand the principles, I can now show the shortcut method. All right, let's look at this question. So in the electrolysis, of copper sulfate using inert electrodes, a current of 15 amps was supplied for 40 minutes. What is the mass of copper formed at the cathode? This is how a question is going to come at you. So let me allow you to copy the question and let us see how we're going to maneuver the question. Now, what is the first thing you would do if you are asked a question like this? What's the first thing you would do? And the first thing you should do is to calculate the charge. So let us work out the charge. So we know Q, which is our charge, is equal to IT. Let's work that out. The current that was supplied was 15 amperes. And the time it was supplied for? 40 minutes. But can we just leave the 40 minutes inside here like that? No, we have to convert it into seconds. So what we do, each minute has 60 seconds. So let's multiply the 40 by the 60 to get it into seconds. Let us see what is our charge now. Didn't hear that, sorry? No, just work out the whole thing and tell me. 36,000 coulombs. All right. So then I'm going to do it a shorter way than how I did it the previous way. Now that we understand the principle, I can do it the shorter way. The next thing I'm going to do now is that I'm going to write the equation for the cathode. Because that's where the copper was formed. Do you remember what process takes place at the cathode? Is it oxidation or is it reduction? What takes place at the cathode? Oxidation or reduction? Reduction. So that means that copper ions are going to the cathode to gain electrons. Now, it depends on the charge that tells you how many electrons you have to gain. So if something is a 2+ charge, then it needs 2 electrons before it can go back to being a regular atom. If I gave you something that has a 3+ charge, then you know it should gain 3 electrons to going back to being a regular atom. Now, from this equation, we must be able to see what is the relationship between our electrons and our copper. So it takes us 2 moles of electrons to give us 1 mole of copper. So this is called a mole ratio. So if we want to make 1 mole of copper, we would need 2 moles of electrons to create that 1 mole of copper. Now, can you tell me what 1 mole of copper would weigh? Based on what we learned about the RMM a while ago. 63.55 grams. So that means that this is what it is saying. If you wanted to make a mole of copper, right? So this is how I'm going to tie it and make your life easier now. If you wanted to make 1 mole of copper, which weighs 63.55 grams, then you would need to discharge 2 moles of electrons to make that 63.55 grams. So this is a statement that is very important because it's going to shorten the amount of calculations you have to do. By just putting in how many moles does it take you to make 1 mole, and then you see how much does that 1 mole weigh. Okay, so we just make a link right here quickly instead of having to do the long route. The next thing we need to know now is how many coulombs, what charge do we need, all right? So let me just put that as my 3rd step now. Step number 3, calculate the charge required to form the 1 mole of our copper. And we know 1 mole of our copper weighs 63.55 grams. Let us see that now. So we know already that 2 moles of electrons would be required. Now let me make it easy. Let me break it down for you. We already had known that if you want to discharge 1 mole of electrons, you need 96,500 coulombs to give you 1 mole of electrons. Remember that? Remember that statement? No. How many moles of electrons do you need in order to make the 1 mole of copper? According to this, we need 2, not 1, right? So if, guys, if it takes us 96,500 to get 1 mole of electrons, then if we needed 2 moles of electrons, that means we would need 2 times that amount of current, of charge, right?
So depends of how many electrons you need?
Yes. So if we needed 1 mole, it would have been 96,500. But because of this, we need 2 moles of electrons to create the copper. So guess what? We're going to say that we need 2 times 96,500 coulombs to give us the 63.55 grams of copper. So I want you to see how I was able to jump and make this statement right here. Because I know how many electrons it needed to give me my 1 mole of copper. I know that in order for me to get 1 mole of electrons, I need 96,000 times 96,500. So therefore, clearly, if I needed 2 moles, I must multiply this number by 2. So if I wanted to get 1 mole of copper, which is 63.55 grams, I needed 2 times the 96,500 coulombs. How much does that work out to give us? So 193,000 coulombs is what I needed to create my 63.55 grams of my copper. I'm going to make a line right here, because now I'm going to make, let me write it down a little bit further, because now I'm going to be able to do my cross multiplication. And I want to show you that where do I start my cross multiplication. So making your life easy now. So I'm going to just write this statement down here to say 193,000, but I just wanted you to know where I got this 193,000 from. And then I just pick it out of the air. All right. So 193,000 coulombs would get me 63.55 grams of copper. But were you supplied with 96,500 coulombs in this cell? No. When you worked it out from up the top, you were only supplied with 36,000 coulombs. Okay? So we needed 193,000, but we never had that much. We only have 36,000 coulombs. So I'm going to write the amount that was supplied. So this is what we needed at the top. But down the bottom, this is what we were supplied with. So we are going to see how much copper can we get from what we were supplied. Clearly, we're not going to get the 63.55 because we don't have that much coulombs. So how much can we get? So that becomes our X. So we had 193,000 to give us the 63.55. We were only given 36,000. So how much copper can we get? That is now what we don't know, and that is our X. And how do we find our X, guys? Cross multiply. So let us do a little cross multiplication now. Now that we have made 2 nice statements. So it would be 193,000 times X is equal to 63.55 times, I don't have to write the units right here. So I'm just writing the numbers, times 36,000. So in order to find my X would be equal to 63.55 times the 36,000 divided by the 193,000. Let's work out the top part and then we can divide it. What would the top part of this equation be equal to? Come again? 2 million. Come again? 2? 800. Divided by the 193,000. So what's the answer we got? It would be 11.35 grams. 85? Okay. So what at the end of this now, we can say that 11.85 grams of copper formed at the cathode. So now you can see that this second time that I did it, I didn't do as much steps. I did it much more quickly than when I did it the first time, because this time now I had laid the principles, so you see why I can just make the shortcuts. So this would be the simple way for you to actually do the calculation using this template that I gave you, the second one, right? All right, now let me see if you really grasp this. I'm going to give you one that I want you to work on for yourselves now. For instance, at home, when you finish, you send me a picture of what you're doing on WhatsApp, and I'll check the person's here. So this is question. All right, let me just phrase it like how you'd see it. During the electrolysis of nickel, so I would say nickel 2 sulfate, a current of 4 amps was supplied for 1 hour. Calculate the mass of nickel to be formed at cathode. And I'm going to be kind and give you the equation for what you expect to get at the cathode. So at the cathode, nickel 2 plus ions are going to gain 2 electrons to become nickel solid. So you are going to do, I'm going to give you 10 minutes to work this out for me to see what mass of nickel I would form if I supplied a cell 4 amps for 1 hour. Work it out, tell me what mass of nickel I would form. I have 10 minutes to send this to me.
Okay, thank you, Miss. Miss, could you show me the example, please?
You didn't get to write it down before?
No, Miss.
You wrote down the question though. So this was the example. That was the example.
Thank you, Miss.
Okay.
Miss, you can bring it back to the question.
That's right. That was right. Is it iron or lithium critical? Right, so person at home, you have 3 more minutes to send me what you have. All right, guys, for the interest of time, I haven't gotten your questions from home, but I'm gonna have to solve the question and show it to you because there's one thing I need to show you for you to be able to do your classwork today. So I want to just go through this one quickly and then show you the classwork. And the classwork is gonna involve you doing electroplating and also you doing calculations. All right, so the first thing you would have done, guys, is worked out your charge. The charge would have been that you had 4 amps, you had time of 60 minutes, and you convert that into seconds. What charge did you get?
It's
14,000.
14,400.
All right, so that means you should have gotten to this part. And then now, from the equation, you could have seen that the nickel is a 2-to-1 relationship, right? So if you wanted to form 1 mole of nickel, you needed 2 moles of electrons. And how much does 1 mole of nickel weigh? What's the Armin? 58.
58.69 grams.
9. Okay. So now you would have made a statement that says that you need 2 farads, because if you need 1 mole, remember that if you need 1 mole of electrons, you need 96,500 coulombs. So with our 2 moles of electrons, we're going to need 2 times that 96,500 coulombs to give us 58.69 grams of nickel. So that's 193,000 coulombs to give us 58.69 grams of nickel, right? So we were only supplied with 14,400 coulombs. So how much nickel would that be? So we will do our cross multiplication. So we cross multiply. Yes? Oh, so it should be 193,000. Thank you. So 193,000. All right, so X would be equal to, so X times 193,000 would be equal to 14,400 times 58.69. So X would be equal to 14,400 times 58.69 divided by 193,000. And when you work that out, it comes out to give us 4.38 grams. So this is what you should have been getting at home. So were you able to get that at home, guys?
Yes, miss.
All right. So that way I only see one person sending it to me so far, and one person that sent it was correct. And there's one last thing I need to show you that's going to come on your question today, and that is for you to work backwards. If somebody tells you how much product you're going to form, how do you go the other way and go back and see how much time you needed? So a question can come like that. All right, so I'll give you a minute to copy this down, and then I'll show you that part. If you're finished, what page is that said? So if you've finished writing this off, go to page 152 of your supplemental notes. Oh, 156. So go to page 156 of your supplemental notes, and I'm going to, so we can look at what happens if you have to work backwards. If they tell you the product and they're asking you to work out the time. Finished? All right, so go to your notes. I'm in page 156. Of the notes. So 156. right? So we are looking at example number 3 on 156, okay? Now this question says, and this example shows what you do if the question is reversed. Make a note of it because you're gonna see. This question says, how long would it take for you to deposit 0.635 grams of copper at a cathode during electrolysis? I want you to make a note of something that is not relevant for this, but it's relevant for your past paper. Note, if you get something in kilograms, you are to divide it by, sorry, if you get something in kilograms, you are to multiply it by 1,000. So just make a note of this now. You'll see why I'm telling you this, to get it into grams. And if you want to get the moles of something, it's equal to the mass over the RMN. So just make a note of these things. If you get a question in kilograms, you have to turn it into grams. And if you want to turn your grams into moles, then you find the RMM of the substance and mass divided by RMM gives you the mole, all right? All right, so let us look at this question which says, what do happen if the question is reversed? This question says, how long would it take you to deposit 0.635 grams of copper at the cathode during the electrolysis of copper 2 sulfate if you use a current of 0.2 amps? So, and they're just giving you some information here to say that it takes 96,500 coulombs to get 1 mole of electrons, and they also gave you the RMM of copper to be 63.5. So they said this time, you normally would have started off by working out the coulombs, but that's not what you're going to do this time because you're going to work backward. So it said this time you can't start by working out the number of coulombs because you don't know the time. As with any other calculation, just start from what you know most about. In this case, you know most about the copper. So let's start with the electrode equation. So the electrode equation says that copper plus 2 electrons give us copper solid, so that there's a 2-to-1 relationship between our electrons and our copper. Write this down in words. So 2 moles of electrons gives us 1 mole of copper. Now put in the 1 mole of electrons as 1 Faraday. So as we learned already, if you know how many electrons you need, then you should know how many coulombs you needed. So we need 2 times 96,000 coulombs to form 63.5 grams of copper. Then we can work out how many coulombs you would need to give the 0.635 grams of copper. Let me help you right here. So they're saying that if you need 193,000 coulombs to give 63.5 grams of copper, what coulomb would you need in order to get 0.635 grams of copper? So this time we know how much copper we form, but we don't know the coulombs. So what we do in a case like this, we cross multiply to solve for X. When they did it, they worked it out and got X to be 1930 coulombs. So this equation, this calculation that they did here, all I did is just I expanded it for you so that you can see it better. This is how they got the 1930, right? Because they just did the shortcut, but I wanted you to see how they did it. So if you can figure out how many coulombs you need, then it's not difficult for you to see the time. So if you did your calculations and you see how many coulombs you need, then look at how you find the time now. They said you now know how many coulombs you need, and you don't know, and you know what the current was in amps. So you now have all the information in order to work out the time. So remember we said that coulombs was equal to I times T. So if you want to find T, T is equal to Q over I. So all you can do is rearrange this information in order to form the time instead, right? So T would be equal to the Q. So Q is equal to IT. So T is equal to Q over I. So all we would have done is put the coulombs that we got from up here, which was the 1930, the amps that they gave us in the question, which was the 0.2, until we got the time to be 9,650 seconds. So this was them dividing Q over the I to give us the T. So this is a question where you work back way. They give you the product and you have to work out how much time it took.